Okay, so now that we understand the particle theory of matter, we're going to look at why matter behaves differently. So why do different types of matter do different things? So we have two targets with today's notes, target 18, 19. 18, you should be able to explain that mass of an object does not change, but its weight can change based on gravitational forces acting upon it. And then you should also be able to explain the relationship between mass, volume, and density, and also be able to calculate and find each of those. And actually, target 19, we're not going to spend a whole lot of time on notes. It's going to be a pretty extensive lab that you're going to do to help you understand target 19. Okay, so matter or substances have different physical properties from each other, and we've talked about this quite a bit. So a physical property is a characteristic of matter that can be observed without changing its identity. So different arrangements of atoms provide different properties. So they have different elements have different melting and boiling points. They have different densities. Again, remember mass is the amount of matter. It does not change. So if you go into space, the mass stays the same. So all matter has mass. Okay? And all that mass, if you take a rock from Earth and take it to the moon, that mass is going to stay the same whether it's on Earth or on the moon. So the amount of matter in a substance always stays the same. That's its mass. Now remember, weight can change because it is a force that depends on mass and the force of gravity. So when we talked about this, if you have a large mass, so like the Earth has more mass than the moon, the Earth has more gravitational pull. So if you go to the moon, you would weigh less because there's a smaller mass than Earth, therefore smaller gravitational pull. So we've talked about this a lot, how if you go somewhere else in space, mass stays the same, but weight will change due to gravity. And you're going to get a left-hand practice to make sure you really understand the difference between mass and weight. Remember, the units for weight is in newtons. Sir Isaac Newton, gravity, the apple. Volume of matter is the amount of space matter takes up. So if we measure the volume of a regular object, meaning it has a certain shape that we can measure the length, width, and height, then the unit would be in centimeters cubed, because you would find length times width times height. You would get length is measured in centimeters, width is measured in centimeters, height is measured in centimeters. So you multiply those three together, and you get centimeters cubed. These are what we call regular objects. Now, if you have objects that do not have, we cannot easily measure the length, width, and height, or if you need to take the volume of a liquid, then you're going to do what's called water displacement. And when you do the lab, there's a whole tutorial which I will show you in just a second on how to find water displacement. So when you do your lab on density, we will have two labs for this set of notes. First lab is physical and chemical properties lab. The second lab will be your density lab. In order to help you understand how to do water displacement, you'll go to under density lab, how to find volume using water displacement. And this is a little tutorial that'll show you how to find volume, okay, using water displacement. Then another particular property of matter that each matter has that's different is density. Remember, density is how heavy something is. So all the elements and compounds have a certain density that are different. Density is mass, that's what the N stands for, divided by volume. So when you calculate density, you will take mass and divide it by volume. Now, one thing you just have to memorize, the density of water is 1, and it's always going to be 1. Density doesn't change for each substance. Now, there's other physical properties that matter has, okay, besides mass, volume, and density. Those include length, width, height, how hard it is, color, viscosity, whether it's acidic or basic, and the phase of matter, whether it's in a solid, liquid, or gas. Those are all physical properties. So when we look at matter, we can look at physical properties of matter. Then we can also look at chemical properties of matter. Chemical properties of matter are characteristics of matter that allow it to change into different types of matter. So matter can change, just like we did with energy, how you can change electrical energy into mechanical energy or electrical energy into light energy. You can do the same with matter. You can change matter from one type of matter to another. In order to do that, you have to have what's called a physical or chemical change. So chemical property is something about that matter that will allow it to change into a different type of matter. Examples: if matter has the ability to react with oxygen, like rusting. So when you stick a nail out, iron nail, and you leave it outside, iron has the ability to react with oxygen in the air and it will rust. An iron nail that rusts means that iron has changed into rust, which is a different substance than iron. If something has the ability to be toxic or corrosive, that's a chemical property. Also, if it's flammable, and I forgot to write that down there, so you want to write flammable. If something has the ability to burn, that's a chemical property because it will turn into something new. This log that's burning is turning right now into a different substance, which will be ash. That's different than the log. It has different properties. And there's an example of rusting. Okay, so by now you should be able to understand, based on a substance's property, whether they're physical or chemical, this is why they behave differently.